Okay, elimination video. You've hopefully chosen elimination. If you are a substitution person, the only reason you should be choosing elimination is because I said in the last video, you maybe want to choose elimination because it tends to be slightly easier, or you've already watched substitution and you felt confused. So, elimination. You are going to essentially do elimination 3 times. So you are first going to pair 2 equations together and complete the elimination method like you have previously learned to eliminate one of the 3 variables. It does not matter which 2 equations you use or which variable you were trying to eliminate, but there are sometimes easier ones to pick, all right? And I'll kind of point that out in your example. So 2 equations, use the elimination method on those to eliminate one of the 3 variables. That is going to give you a new equation because you're still going to have 2 variables. So if you eliminate x, you should still have y and z in that after you eliminate. You are not solving right now. You're just doing that. You're going to stop and you're going to start over, pairing a different set of equations from the original problem. So obviously you have to reuse one of the ones you used here and then use the one you haven't used yet. You must eliminate the same variable that you eliminated up here in step 1. So when I paired these first 2 equations together, if I eliminated x, now when I pair these 2, I have to eliminate x. All right? So after steps 1 and 2, you now should have 2 new equations with the same 2 variables, y and z only, or x and z only, or whatever. Now you're going to use those 2 equations and eliminate for the 3rd time. So if you have y and z in the first and second equations, use elimination to now eliminate y or z. Now you will eliminate down to only one variable. So now you are going to solve for that variable. Solve for y. Once you have y, use that value for that variable and substitute it back into one of the equations you started with in step 3. So the equation you got from here or here that you used in your elimination in step 3. Plug that variable in so you can solve for that other variable in the 2 variable equation. So now you have the answer, the solution to 2 of your variables. Now use both of those to plug back into one of the original equations to solve for your 3rd. Now you should have all 3. And I will show you how you can check them if you want to be able to do that. So let's put all that together. We are going to pair 2 of the equations together to eliminate one of the variables. Keeping in mind that step 2 is to pair another 2 set of variable equations to eliminate the same variable. So I want to point some things out here as you are getting started. Some suggestions, some ideas. If I look at my x's, I have 1, 2, and -1. Those are going to all be pretty easy to eliminate because this 1 and -1 will already eliminate. And I can easily change a -1 into the opposite of 2. Similar with your y's, you have 1, -1, and 2. You have the same number, so just by coincidence, they're in a different order. But same thing, those would be pretty easily to pair 2 of them together to eliminate. But here I have 1, 3, and 2. Those are going to be harder. So not difficult, not too difficult, but harder than eliminating x or eliminating y. So you still could, because you can 1 and 3, you can make those into opposites, and then 1 and 2 you can make into opposites, but just slightly harder than eliminating x's or eliminating y's. Your goal is to eliminate one of the 3 variables the first time you eliminate. So you start by picking 2 equations. I'm going to use the top 2. So I'm putting a 1 here. This is step 1. I'm going to use elimination. Now, you decide right now, do you want to try to eliminate x's, y's, or z's? There is no wrong answer. Depends on what you see and what you want to do. I might want to eliminate my x's, and I can do that, and I'm going to have to eliminate that in a specific way. I might want to eliminate my y's or my z's, doesn't matter. I am going to point out with these two equations, right now, my y's will already eliminate. So I'm going to eliminate my y's. So all I need to do is just add my two equations together. 1 plus 2 is 3x. Y minus y eliminates. 1 plus 3 is 4z. And 6 plus 9 is 15. That's as far as I go here. I stop. I'm supposed to have two variables. Now, if by chance, when you did that elimination, you actually were left with only one variable, you could solve for that variable. Okay, so if by chance my z is also eliminated, I now could solve 3x equals 15. I could solve for x. But that's not typical. Typically, you should get this. Now, step 2. I need to go back to the original and pick one of these I've already used and the one I haven't used. So I know I have to use this bottom equation, negative x plus 2y plus 2z equals 9. And then either of the top two, does not matter. But I have to eliminate the y's because I already eliminated the y's. So you might look at this and say, oh, well, x and negative x, let's use the top one. But it's not helpful to eliminate x's because I didn't eliminate x's here. So instead, I'm going to use this middle one, 2x minus y plus 3z equals 9. I'm using the middle one because I now already have a positive and a negative. I just need to turn this y into a negative 2y, which I would do by multiplication, just like I always did with elimination, multiplying the entire equation by 2. And why 2? Because when I distribute that to everything, 2 times 2 is 4x, 2 times negative y is negative 2y, 2 times 3 is 6z, and 2 times 9 is 18. Now I have these opposites, 2y and negative 2y. So I'm going to just rewrite this top equation underneath. And now I'm going to add those two equations together. 4 plus negative 1 is 3x. Negative 2 plus 2 is eliminated. 6 plus 2 is 8z. And 18 plus 9 is 27. Now I look. I am supposed to have two equations with the same two variables, x and z. Perfect. Okay. Step 3. Take those equations, 3x plus 4z equals 15, and 3x plus 8z equals 27. All right. Now we're going to eliminate using those two equations. This is literally elimination that you learned in the last lesson. It's x and z instead of x and y, but it's the exact same thing. Two variables, two equations. Eliminate one of them. I can notice I have 3 and 3, so all I need to do is make one of them negative. Or I can even see I have 4 and 8, so I can make this times this by negative 2. Up to you. What do you see? What are you able to see with this problem to solve? I'm going to do times this top one by negative 1. That's going to turn that into negative 3x minus 4z equals negative 15. You could have multiplied that top equation by negative 2. That will eliminate your z's. You could have multiplied the bottom one by negative 1. I chose the top one just so I didn't have to rewrite this equation, whatever. It's already there. Now I can just add these together. 3 plus negative 3 eliminates. Good. 8 plus negative 4 is 4z equals 27. Uh-oh, hold on. My lights went out. All right, sorry about that. Automatic lights turn off after a while. Where were we? Oh, 27 plus negative 15 is 12. Okay, now I can solve this equation. 4z equals 12. So z equals 3. There's one of my answers. Okay, step 4. Now that I have that, I'm going to take either this equation from step 1 or this equation from step 2 and plug that number in for z. Doesn't matter which one. Pick one. I'm going to pick the first one. So 3x plus 4 times 3, because z is 3, equals 15. Let's solve. 4 times 3 is 12. You have a plus 12, so you need to subtract 12. So 3x is going to equal 3. So if 3x equals 3, that means x equals 1. Now, you're going to take both of these and plug them into one of the original equations. And it doesn't matter. Now, here, it really didn't matter at all. Here, it may or may not matter, but I'm going to point out that this top one says x plus y plus z equals 6. That's going to be a lot easier to solve than any of these bottom two. So I'm going to plug in x is 1 plus, I don't know why, plus z is 3 equals 6. 1 plus 3 is 4. So y must be, what plus 4 equals 6? 2. So y equals 2. So now my answer, put them in order, x, y, z. 1, 2, 3 is the solution. And now I'm going to show you how to check them because I told you that that's a possibility, which I highly recommend you do that because this is complicated. You do that by taking these numbers, plug them in for x, y, and z in all three equations separately. So the first one, that one's easy. 1 plus 2 plus 3 equals 6. Good job. Okay, 2 times 1 minus 2 plus 3 times 3 equals 9. Good. Negative 1 plus 2 times 2 plus 2 times 3 equals 9. Good job. I know that they're correct because all three equations came out to equal what they were supposed to equal. So, pick any two to eliminate a variable. Get an equation with two variables. Use the one you haven't used and one of the ones you already used to eliminate the same variable again to get another equation with two variables. Use those two equations to eliminate a third time to get you down to only one variable so that you can solve. Use that answer in one of your two original elimination equations. Plug it in to solve for a second variable, and then use both of those variable answers into one of the original to then solve for the third, writing your answer in order alphabetically X, Y, Z. Not numerically. This is just fun coincidence. 1, 2, 3. All right. X, Y, Z. The only reason you need to watch the substitution video is if this was super confusing and you want to try substitution, or you tried elimination and it's really not working for you and you want to look into it. But do not watch substitution if this makes any sense to you. It's not going to be perfect right away. This is a hard lesson. But if this makes even a little bit of sense to you, start doing some practice. I highly recommend that you do one problem with me together. So, let me know when you are ready to do one, and we will do one together.